Okay, it is 6 o'clock, so let's go ahead and get started. Can y'all hear me on y'all's end? Can anyone hear? Okay, so I see people saying yes. I see people giving thumbs up. All right, wonderful. Okay, so as y'all know, this is the last class before our first test because we do not have class on Monday. Monday is Labor Day. So we are having our first test a week from today, or at least I hope everyone knows that. So the purpose of this class, it's going to be really short. The only things I have prepared is I'm going to cover very briefly some very general what's going to be on the test, very, very general, because the test will be open book. So I didn't want to give anything like a study guide or any example questions because you would have access to it and that would just make things too easy. So I'll give some general information and then I will briefly go over what we covered on Monday because that was a lot of new information. That was a lot of complicated stuff. So I'll go over that again briefly and pretty much just tell you what you'll be expected to know regarding that information on the first test. So once again, just going over a little bit of what we covered on Monday and directly saying, here's what you need to know for the first test in regards to that material. Also, as a side note, you do have homework due. The homework is due on Sunday, so don't forget to do it. Make sure you do the homework. Several people have already done it. There's already been several people who got 100. So good job if you're one of those people. Okay, so before I start, do y'all have any questions about anything whatsoever? Any questions about the class or the test? You can either unmute your mic or you can type it into the chat. I do have the chat window open. Okay, not hearing anything, not seeing anything. So, one person says, do we need to log into Zoom? That is a wonderful question. You do not need to log into Zoom. You do not need to log into Zoom. For the test, it will be on Canvas. It will be from 6 to 8. So all you need to do is log into Canvas starting at 6, take the test, and make sure you finish by 8. Another thing now that I'm bringing that up, I would also recommend, Canvas is supposed to automatically save your answers whenever you type them. That's how Canvas is supposed to work. It's just periodically automatically saves. I would also highly, highly, highly recommend every now and then copying your answers into a Word document because every semester, no matter what happens, I always have one student who says, oh, I typed in all my answers and then Canvas crashed and deleted everything. So that's just a side note is I would highly recommend, in addition to typing your answers into Canvas, make sure you copy and paste them and put them into a Word document. But long story short, you do not need to log into Zoom to answer that question. Okay, any other questions or comments about the class, about the test, anything at all? Okay, I do not hear anything, I do not see anything, so I'm going to move forward. First, this is the one slide I wanted to show about the test. This is the breakdown of the test from last year. I'm assuming the questions will be different from last year, but I'm assuming I'll probably cover the same content area. So the numbers represent the questions. So as you can see for chapter 1, which is the very top one right there, there were 5 questions last year about chapter 1, and those were worth 20 points. So that's how you read this slide. This also, by the way, all the PowerPoints are on Canvas, so you don't have to write this down in a hurry. You can just go to Canvas and download this PowerPoint. But last year, we had 5 questions on chapter 1, and they were worth 20 points. We had 3 on chapter 2, and they were worth 6 points. We had 2 on chapter 6, and they were worth 6 points. We had 5 questions on chapter 7, and they were worth 22 points. We had 4 questions on chapter 8 and 9, and they were 9 points. And then we had labeling a formula, which was 14 points, calculating probability, which was 9 points, and calculating descriptive statistics, which was 14 points. So you can see the score breakdown right there. I don't have any major advice to give. I would say, of course, focus on the things that are worth more points. So things that are worth more points are chapter 1, chapter 3, and then chapter 7 are particularly worth a lot of points. So 1, 3, and 7 are worth a lot. But make sure you do study everything, of course. Anything we've covered in the lecture is fair game for the test. So make sure you do study everything. Yeah, I think that's all I have to say about that slide. Chapter 1 is just general stats information. So as you remember on the first day of this class, we went over a lot of terms, a lot of definitions. So for studying chapter 1, make sure you know those terms, make sure you know those definitions. For chapter 7, what is chapter 7 is sampling, I believe. So population, samples, sampling approaches, bias, systematic bias, not systematic bias. So make sure you understand sampling really well, because that is chapter 7. And then chapter 3 is descriptive statistics. So make sure you understand how to calculate descriptive statistics, and then also make sure you understand how to label a formula if I were to present you a formula. So, okay, so that's all the questions that are going to be on the test, or probably something roughly close to that, because this is what it was last year. Any questions or comments about that? Okay. If there are no questions or comments about that, I'm now just going to go through very briefly what we covered on Monday and what you'll be expected to know about it for the test. So if you remember, on Monday, we covered confidence intervals and p-values. And this is an extremely important topic. I know it can be confusing. That's okay if it's confusing. We're going to go back through it throughout the semester, but I want to make sure you have a good core understanding of it for the first test. So for the first test with confidence intervals and p-values, I want you to, of course, be able to recognize what the difference is between a population and a sample. So a population, the entire group we're interested in. A sample is a subset of the population. So I think it could be a very reasonable question for me to ask you, what is a population? What is a sample? And then I might also ask you which one of those is associated with a parameter, which one of those is associated with a statistic, and what is a parameter in a statistic? So you should be able to say that a parameter is a statistical attribute of the population, and a statistic is a statistical attribute of the sample. So you should be able to define these 4 terms because they're essential to understanding statistics. So population, parameter, sample, and statistic. Next, we talked about a sample statistic won't estimate the population parameter perfectly. That if you have a population parameter, the average age of the population might be 27, but your sample statistic might be 26.5. It's not going to be perfect. So you have to think, well, all right, since we know it's not going to be perfect, what do we do? How do we address some of that margin of error? And the answer is confidence intervals and p-values. Because the sample statistic won't estimate the population parameter perfectly, we have to calculate confidence intervals and p-values. So first, we'll just go over what confidence intervals are. So from our sample, we can calculate a confidence interval. So a confidence interval is calculated with a sample. And a confidence interval, in plain speak, is a range of plausible values for a population parameter, but it is not a guarantee. So it's a range of plausible values for a population parameter, but it is not a guarantee. So once again, if I were to give you a question that says, what is a confidence interval? I would mark that as a correct answer if you wrote a range of plausible values for a population parameter, but not a guarantee. So therefore, based on that, if a value falls outside of this range, it is not a plausible value for the population parameter. So if your confidence interval is 0.1 to 0.3, that would mean that 0 is not a plausible value for the population parameter because 0 would fall outside of that range of 0.1 to 0.3. And this is a visual representation of what we might think of when we're conceptualizing, trying to get my draw tool, give me one sec, population and a population parameter. And then this would be a sample, or these are the samples. And then this would be the confidence intervals for each sample. So like we talked about, for each of these samples, the confidence interval is the range of plausible values that the population parameter might fall. So for all of these samples, these are their confidence intervals. And you can see for these samples that I'm highlighting, their confidence intervals do include the population parameter. However, as you see with this one over here does not include the population parameter. So therefore, this is one of those unlucky 5% chances that your confidence interval does not include the population parameter. So that's why we say it's not a guarantee. That's why we say it's not a guarantee that it includes the population parameter, because you could be one of these unlucky 5% that do not include the population parameter. Okay, and then I think this is the last thing I want to say about confidence intervals. Is, let's say, for example, a 95% confidence interval for a correlation between X and Y is 0.03 to 0.12. So that means that based on our sample, we would say a plausible range of values, there would be the correlation between X and Y in the population would be 0.03 to 0.12. Typically, when we're performing a correlation, our hypothesis is that a relationship does exist. So our hypothesis is the correlation is not zero. Our hypothesis when testing a correlation is typically that the relationship is not zero. So therefore, the null hypothesis is that there is no relationship, that the relationship between X and Y or the correlation between X and Y is zero. Whenever you're talking about correlations, no relationship is a correlation of zero. So therefore, based on that, can we reject the null hypothesis? So based on this confidence interval for our sample, can we reject this null hypothesis that I have underlined? What does the class say? Can we reject the null hypothesis? Okay, yep, I see one person say yes, one person say no. The answer is actually, oh, I see two people say no. So maybe this is something we need to review a little bit more. We actually can reject the null hypothesis. We actually can reject the null hypothesis. And the reason is this, our range is 0.03 to 0.12. The null hypothesis is 0. So 0 falls outside of this range. 0 falls outside of this range. So therefore, 0 cannot be a plausible explanation for our population parameter. 0 cannot be a plausible explanation for our population parameter. So because 0 is outside of this range, we say it's not plausible. So we can reject 0 being a plausible answer. So therefore, we can reject the null hypothesis. Therefore, we can reject the null hypothesis because the null hypothesis is no relationship exists. The null hypothesis is R equals 0. And because 0 is not within our confidence interval, we can reject that as a plausible explanation, and therefore we can reject the null hypothesis. Therefore, we can reject the null hypothesis. Okay, so that's how confidence intervals work. Are there any questions about confidence intervals? Any questions about confidence intervals? Okay, one person says, I think I misunderstood the question. So yeah, so that's the language that's common in statistics. It is confusing, I acknowledge that, but that is the language that statisticians use of reject versus not reject the null hypothesis. So if that is one thing I would say is important to review, is just get used to this language because that will be the language on the test. You know, rejecting versus not rejecting the null. So therefore, review the language, review all of this concept with confidence intervals. I see someone asking for the homework assignment due this week. What chapters is it covering? The homework assignment's about probability. So what was that? Chapters 6 and 7, was that correct? Anyone remember? It's about probability. So whichever chapters were about discrete and continuous probability. I see one person agreed with me that it was 6 and 7. So yeah. So it was about discrete and continuous probability. So, okay. Any other questions about confidence intervals or anything else before we go into p-values? Okay. All right, so p-values, so we can also get a sample and we can also calculate a p-value. So just how we could calculate a confidence interval for a sample, we can also calculate a p-value. And a p-value is very simple. A p-value just tells us the likelihood of obtaining our observed results if we assume the null hypothesis is true. So it's the likelihood of obtaining our observed results if we assume the null hypothesis is true. So therefore, we might collect a sample. We might get a result that's something like R equals 0.20. We might get something like R equals 0.20, which you see right there. We also might get a p-value, and our p-value might be something like P equals 0.02. So R equals 0.20, P equals 0.02. So what a p-value tells us, if we assume the null hypothesis is true, once again, the null hypothesis for the case of a correlation being 0.00. So a p-value tells us if we assume the null hypothesis is true, if we assume that the if we assume the population correlation is 0.00, then we only had, let me go back to my draw tool, then we only had a 2% chance of getting a correlation of 0.2 in our sample. So all it says is if we assume this is true, if we assume the null hypothesis is true in the population really has a correlation of 0.00, then we only had a 2% chance of obtaining a correlation of 0.2 in our sample. Once again, this being what we actually observed, and this being what we calculated from our data. So that's what a p-value is. Once again, if I asked you on a test, what is a p-value, then this is what I would expect you to answer. I'm pretty finicky about this. I will directly say if you tell me a p-value is the likelihood that the null hypothesis is true, then I will mark that as incorrect. If you say a p-value is the likelihood that the null hypothesis is true, I will mark that as incorrect because that's not what it is. A p-value is the likelihood of obtaining our results if we assume the null hypothesis is true. It is not the likelihood that the null hypothesis is true. And I am very finicky about that. I will mark that wrong. Even if you come up to me and say, I had a different professor that said that's what that is, I will say, give me the name of that other professor. I will send them an angry email for teaching you wrong. So I am very finicky about that. Okay, so then based on these results, if we're unlikely to observe our results if the null hypothesis is true, I think that's supposed to say then, yeah. So that's supposed to say then we, not then the new. That's supposed to say then we reject the null hypothesis. So that's supposed to be that right there, and these are supposed to be switched. So it's supposed to say if we were unlikely to observe our results if the null hypothesis is true, then we reject the null hypothesis. So all this says is if we were very unlikely to observe our results, if we assume this is true, then we can assume that it's not true. Then we can reject the null. So for the cutoff for this is 0.05. So our results are statistically significant if our p is less than 0.05. We can reject the null if the p is less than 0.05. So if our p is less than 0.05, we can say that the null hypothesis is probably not true, so we can reject the null. So therefore, we can reject the null if this is less than 0.05. Okay, so that's all you need to know about that. So once again, in a very quick summary, p-value tells you the likelihood of observing your results if the null hypothesis is true. If your results were very unlikely to occur, so less than a 5% chance to occur, if the null hypothesis was true, then you can reject the null. If your observed results were very unlikely to be observed, if the null hypothesis is true, then you can reject the null hypothesis. And once again, p less than 0.05, we reject the null. Someone said, can you read the correlation you made again? Or sorry, read the correction you made again. Yeah, so all the correction was this is supposed to say then we. So this right here is supposed to say then we. So if we were unlikely to observe our results if the null hypothesis is true, then we reject the null hypothesis. And I'll just type it there to be easier. And then that's what it's supposed to say. Oops. Okay, any other questions or comments about that? Going once, going twice. Okay, I'm going to clear this. And then this is, I believe, the last slide I had prepared today. So let's say we calculate a correlation between X and Y, and our p-value is 0.03. Can we reject the null hypothesis? If our p-value is 0.03, can we reject the null? See, one person said yes very quickly, and that person is correct. So good job. If your p-value is less than 0.05, you can reject the null. This is 0.03. 0.03 is less than 0.05. So in this case, we would reject the null. So good job on that. Okay, so that is everything I had prepared to cover today. Once again, we briefly went over the content that will be on the test, and then we went over confidence intervals and p-values, and everything I covered is what you might be expected to know on the test about confidence intervals and p-values. So if you listened to this 20-minute lecture and you understood it, then you're fine, you're good to go. If you listened to this 20-minute lecture and you thought that this was very confusing, you didn't get it, if you thought it was confusing, you didn't get it, then maybe review the material more. Okay, someone just sent me a message. Can you review how to phrase when we reject the null? I believe I just want you to know that just the phrasing of, for p-values, if your p is less than 0.05, you can reject the null or you fail to reject the null. So if your p-value, I'm going to draw this real quick. So if p less than 0.05, you reject the null. There you go. And if your P is greater than 0.05, you fail to reject the null. Okay, and that's the phrasing that we use in statistics. It's either P less than 0.05, you reject the null, or P greater than 0.05, you fail to reject the null. Because all of this is about null hypothesis significance testing. We're more testing the null than we're actually testing our own hypothesis. But that gets into stats theory, but I just want you to use the correct language, even though we're not digging into that stats theory too deeply. Okay, so very good question on that. Any other questions or comments? Someone asked probabilities. Do we need to know how to calculate all the different rules of probability? And the answer is yes. You will need to know how to do that. The answer is yes. So make sure you know the multiplication rule, make sure you know the addition rule, the complement rule, make sure you know all of those. I will say for those questions, I'll probably try to keep it as simple as possible. So for a lot of those questions, the variables will be mutually exclusive, things like that. So once again, I'll try to make it easy. So if it's probability, the variables will probably be, if it makes it easier to be mutually exclusive, then they will be. If it makes it easier for them to be independent, then they probably will be. So there's a lot of probability caveats. Just make sure you understand the general rule. Just make sure you understand the general rule. Someone asked, do you need Excel? I will say Excel would be very helpful. You probably will have questions I'll ask: mean, median, mode, standard deviation, variance. You could do it by hand. When this class is in person, I get the students to do it by hand. But since this will be online, since you will get to take it on your own, you can use Excel. So I would highly recommend using Excel. Also because that's one reason why you get 30 minutes less. It's because usually when this class is in person, it takes about 30 minutes to do those calculations by hand. Since y'all have access to Excel, I expect y'all to use it. So therefore, yes, please use Excel on this. Okay. Good question. Any other questions or comments? Where did you say we learn how to calculate multiple modes in Excel? That is on my website, mattchoward.com. If someone could, just shoot me an email and I will send that link to the entire class. That's a guide on how to calculate multiple modes. So if someone doesn't mind, please send me an email right now and I'll be sure to send y'all the link to that. But my website, mattchoward.com, does have a guide on calculating multiple modes in Excel. So, and I can send that out to y'all if someone sends me an email reminder. Someone asked, do you expect us to calculate z-scores or use tables? The answer is yes, you could be expected to do that. You could be expected to do the z-score calculation, the z-score probability tables like we did in class. If I ask you to do that, I will provide you the tables. So you will not be expected to search for the tables on your own, but you could be expected to do that. So if I feel like it could be reasonable for me to ask, what percentage of the sample, if we assume a normal distribution, falls within -1.5 z-score and +1.5 z-score? So it could be less than a z-score, greater than a z-score, or a percentage between two z-scores. Thank you for that. Someone just now sent the Matt C. Howard link to multiple modes in Excel, so I don't need to send it to y'all. It's right there in chat. So if that's a question you had, be sure to check on that link. So thank you for that. Who is that? Ryan, I believe. So thank you for sending that to the chat, making my life easier. Okay. Any other questions or comments? Any other questions or comments? Okay. So once again, I think the best way to study for the test is to review the lectures. Everything that we covered in a lecture could be on the test. I usually do not put anything on the test I did not directly cover in class. So anything we covered in class or anything on the test will be something we covered in class. I can almost guarantee that, almost 100% guarantee that. So if you're unsure about things, rewatch the lecture videos. Also feel free to watch the videos from prior semesters. They're pretty consistent. So if there's anything this semester that I covered and you're like, man, he did a really crappy job of covering that, check out my video from a prior semester. Maybe I did it better that time. So I would recommend that. But are there any closing questions? All right. Well, that's all I had planned for the day. I think I have one group who's meeting with me after that. So if you're that group, stick around in this video. But otherwise, thank you all for joining me and good luck studying for the test. Have a good one.
Thank you, you too.